So we're going to write an exponential equation for this, then use it to predict. So my base equation is this, and I could use a continuous growth model. It's no harder. It's just I don't do that usually unless they ask me to. Okay. Either way works. I'm gonna use this one. So they're telling me that we start with 100 milligrams. So that tells me that A is 100. Then they're telling me after 35 hours I have 50 milligrams left. So that's Y equals 100 times B to the 35th. And then solve this for B, divide by 100, gives you 0.5. And then just like if you have B squared equals something, you're going to take the square root. Well, we're going to take the 35th root. So I'm going to raise both sides to the 1 over 35. Okay, I can't write that well. I'm on my calculator. So that's what my calculator is telling me that 1/2 to the 35th root of 1/2 is. So that's the B. Notice that it is less than 1, and that's good because this is decaying, and I don't want it to grow. I want it to be decaying or decreasing. So the base has to be less than 1. So what's our equation? I'm going to write it as f of t, or y, equals 100 times 0.9804 to the t power. So now how many milligrams should be left after 54 hours? So you're just going to replace the t with 54. And I'm getting about 34.3 milligrams. Okay, and it's that easy. I could have done that same thing with the exponential equation, the continuous growth model, and I would have had a different k, but I would have got the same answer. Okay. While we're at it, we might as well do one that's growing. This is on the same page. So they're telling us at time 0, it's worth 110,000, and then 5 years later, or 10 years later, no, it's 20 years later, isn't it? It had gone up to that. Now they're asking us what's the annual growth rate. So let's set up an exponential growth equation. So 110. I'm going to be lazy and just use 110. Know that my answer is going to be in thousands. Okay. Now I don't know what B is. So let's see. Then I know that it's worth 145,000. 25 years later, or 20 years later. Yeah, 20 years later. So the same deal as the last one. Divide by 110 gives us what? So I'm getting 1.3182. And then I'm going to take the 20th root. That's giving me 1.0139-ish. Okay. Feels like I've done this problem just this week, but anyways. So that's the base. Now we got to remember that this is in the form 1 plus r, where r is my growth rate. Well, if I just look at the 0.0139 part and make that a percentage, I'm going to get a growth rate of 1.39% or so. Alright, so that's the annual growth rate. Now they're asking us to assume it continues, so that tells me my equation's 110 times 1.0139 raised to some power and some time, and 2010 was what, 25 years after 1985. So we're just going to calculate that. I won't bother with this, showing you the calculator with this, because it's the same kind of deal. So on my calculator I'm getting 155 155, and this is thousands, so I'll do some rounding. So that's what the house has increased in value by 2010. Okay, so I hope that helps you with working out these kind of problems.